Okay, in this video, we will work through some basic stuff that you might need to consider in the context of our projects and how you need to submit them. Okay, so this is one of the first R projects in this course, and we're going to basically deal with some R basics. One thing I want you to keep in mind is that the goal here is not to learn how to program in R, but just pick up essential skills that will help us understand statistics better. Okay, keeping that in mind, so the first thing that we will need to know is how to assign uh, uh, values to variables, and this is the assignment feature. So that's the first consideration to check. So for example, I can assign to X the value 5, right? And I can run this block, and you can see that X has been assigned the value 5. And now if I try to run the output of X, press Control Enter if you're using a Mac, you will see in the output that you get the value that is stored in the variable X. There are other things that we can also assign. We can assign vectors. So the way to assign a vector to a variable X would be to use the concatenate function C. And now if I assign 1, 3, 5, this is a vector that contains numbers 1, 3, 5 to X. Now I have overwritten the value of X with this new vector. And if I print the output of X, you will see that you get the vector 1, 3, 5 down here in the console. Okay, you can also use the print function to do the same. So if I print X, I will now see it printed as a vector. Yeah. So if I were to run this code block, the print command is going to explicitly output whatever is stored in X. The next thing that we will need a lot is the ability to construct lists of numbers. And the way we achieve this is by using the sequence command. So for example, if I use the sequence command, one thing to keep in mind is you can always check out the documentation for a given command by pressing a question mark and then running that command. And you will see that the documentation shows up in this lower right-hand corner. And the sequence command is part of the R base library, and it kind of helps you generate sequences. Yeah, so there are various inputs to the sequence command. You can give the input from where you want to start the sequence to where you want to end it. Default values are 1 and 1. And then you have either an option to give the sequence command the gap between numbers in the sequence, or the total length of the sequence that you would want to use. Yeah, so you can have the length dot out as the input. So let's generate two kinds of sequences. So let's say X1 is a sequence that is generated from 1 through 10. And if you just run this guy and you print X1 or run X1, you get a sequence of numbers going from 1 through 10. And if you provide no additional input, that's all that you are going to get. So X sub 2 is now going to be a sequence. I do the same story, 1 to 10, but now I can add the by condition, and this is going to say that I want a sequence which has 0.5 increments, and I can save this value. And now if you print or see what X sub 2 contains, you can see the output is 0.1, 1.0, 1.5, 2, 2.5, all the way up to 10, right? So the length of the sequence X2 now is the total number of elements inside the vector x2, and you see that there are 19 elements. What I could do is, instead of giving the by command, I could actually output a sequence of a given length. So x sub 3 could be a sequence that is between 1 and 10. And now I give the output len length dot out, right? That's the input over here. You can see length dot out equals, say, 100. So I will get a sequence of length 100. And oh, what did I do? Something is wrong here. Length length. Okay, out. And now you can see x3 is a sequence of length 100 between 1 and 10, right? You can calculate the length of x3 and you will see that this is going to be 100. Yeah, so that's a sequence of 100 numbers equally spaced between 1 and 10. Okay, we will often need this because what we want to do is offer plot functions, and we will want to input the x variable inside the function, and the length dot out, being able to calculate sequences, is going to help us identify the x variable for the sequence. Yeah, so I'm instead of trying to work this problem out, let me try to write a function now that helps you calculate the fourth power of a number, right? So this is going to be a function that takes input a number, right? And then it does the following thing. So this is the syntax for a function, okay? So it takes the number and it returns the number to the fourth power. Okay, by the way, so if you have 2 and I want to say 2 to the 4, check this out, it's 16. So that's how you get the exponent. Yeah, so that's number to the fourth power. So now if I run this, I will get the sequence, and now you can run this function, right, to check that you're actually getting the right number. So if I know 2, I know that 2 to the 4 is 16, and if you run the function, you get 16. If I run it on 3, what is 3 to the 4? Yes, to 81, right? And you end up getting this answer. So this function now is taking input whatever number you take, and it is spitting out the fourth power. Now, I want to plot these guys. So if I want to plot various functions, there are input functions for sine. So notice that the sine function, then you have the cosine function in base. This is going to plot the cosine. Then you can plot the tangent function in R base. You're going to get the plot of the tangent. So all of these are already there. I will just show you, once you have a function, how do you plot it, right? So to be able to plot a function, you first need to identify the x values, the range in where you want to calculate the function. And the way we will identify the x values is by using the sequence command. And I'm going to choose a range. Now, in this problem, we are asked to plot the cosine function between 0 and 10, and you are asked to plot the square function between 0 and 2. So I'm going to plot the fourth power function between 0 and 5. Yeah, so I'm going to draw a sequence of numbers between 0 and 5, and the length of this sequence is going to be long enough, say 1,000 numbers. Okay, and now what I want to do is I want to use the plot function, or I can calculate the y values, right? So the y values are going to be equal to the fourth power function applied to x values. Okay, and this is a nice feature about R. If you apply a function to a vector, it's going to apply the function to each value inside the vector. So now you will get each index in the y values is going to correspond to the function fourth power applied to whatever was in X values over here to the fourth power. So this is how I will evaluate this guy. Now I can use the plot function in our base to plot X comma Y, right? So you can check the help documentation for this. But for now, let's plot X values against Y values. Okay. And what is the plot we get? We get this plot coming up. So now there are various features to a plot, and you have to make sure that the plot has a title, the plot has a bit more information than just looking like a thing that it's not clear what really the plot represents, no? So to be able to identify this, let's look at the documentation for the plot function, right? And if you look at the default generic XY plotting in our base, this is the documentation that we have. So there are various kinds. I mean, these are the two inputs you'll get, X and Y. Then you can identify the type of plot, right? So let's put in type equal to L. So this is going to give us a line plot according to this documentation. And if we run this plot command, notice that the plot is looking a little nicer, correct? We can change the color even. So let's get the color in. So what do we get for the color? How do we change the color? So notice that the color function, where are we? Is there a color option? So there is colors. If you have color equals, say, red, right? And I run this command, and then I have the plot in red. Then I can put a title. So to get a title, you will have main, and then this is, the title will be plot of the fourth power function. Yeah. Now you see you have a title for your plot. Then you can add X labels. Notice you have the X label command. So X label is equal to X, and Y label is equal to just Y. And now notice that if I run this, the Y values, the default value is the name of the variable that you have used for that axis, but now you're going to get X and Y in your plot. Okay. Now notice that the plot does not have a horizontal and a vertical line that identifies the zero. So we can put a horizontal line. So you can have a H line. How do we get lines in there? I'm assuming that okay, so for now, let's leave it at this and can work on the plot. Okay, what I can do is on this plot, I can add a line. So AB line, H equals 0, V equals 0 is going to give me two lines, one horizontal line at 0 and a vertical line at 0. And you notice that now the plot looks a lot nicer. Yeah, so we get a plot. So notice one thing you have to keep in mind, you'll have to run the full chunk to be able to see the plot. Okay, so if you just run it line by line, it won't run because the AB line feature needs a plot to point to, and the only way that is possible is if you run the full chunk. So that's the basics of being able to plot functions. Working with data in R. So this is a data set. You can load the data set by just using the data command. Okay. So if you use the data command and you say iris, this is a data set in R, it's a very famous data set. You can notice, load the data set. There are various things you can do to a data set. Okay, so the data set is stored as a data frame. You can check out columns inside the data frame. You can use what is known as the head command to identify what the data frame looks like, the first 6 rows of the data frame. You can look at the data frame inside here in the left-hand corner. You can identify the data set by looking at it here. The data set is not too big. It loads pretty nicely in the memory. So the iris data set, for example, is going to be easy to analyze. It only has 150 observations and 5 variables. Okay. So you can identify these things. I would encourage you to check out documentation for using or accessing rows, columns inside a data set. It's quite well understood. So I don't want to get into the details of this. The crucial thing you will have to work with is the package dplyr. Okay, so this is something that you will have to get. So package, how do you load a package? We will have to identify, load the package dplyr. Okay, so let's load the package dplyr. So the way you will load it is by using the library command, and you load the package dplyr, and you will get your package. And inside the dplyr package, various commands that you will want to be able to understand is the filter command, right? And so forth. I don't want to go into the details of this. This is part of your project, so do figure this out. Box plots for iris, once you do the following, right? Well, a command that you could be interested is the following. So what we want is we want petal length for a box plot for the petal length. So let me give you a description of box plots for one of the other variables, and then you can just modify this quickly to be able to see the box plot for maybe another variable. So say I can use this box plot command. I don't want you to, I'll give you a box plot for, in the petal length in this case is quite straightforward. You can use the box plot command. So this tells you that we're going to use data iris and we're looking for petal length in the species. So if I run this guy command, you can see that we get side-by-side box plots for the 3 different species and the box plots over here. The box plots are telling you that there is a lot of variation within the species for Virginica. There's a lot of variation within the species for versicolor, at least in the data, and there's much less variation within the species for setosa, right? And there are other forms of inference that you can make a guess for over here, but that's something that we will not bother about yet. Okay, so you can modify the same command that was put up there with the sepal width, and you can get some understanding for box plots for sepal width. So here is a data set. To be able to understand this data, you kind of need to use the histogram function. So just look up the histogram function, and the histogram function is going to kind of give you various inputs. So play around with that, and you should be good to go with this part of the project too. That is about all. So finally, to end the project, what we need is we need a file that is knit into a file that you can use to submit, right? And how do we knit a file? So first thing you will have to do is you'll have to put your name over here. So put your name, right? And your UID. If there are more than one person in your group, put the names of everybody who is in the group. Now I want to knit this file, so I will knit it, okay? And the knit file is going to end up showing up in the folder that contains your original RMD file. Does it make sense? So my RMD file is contained in this folder called R1, so I can knit this file. And if you don't have the relevant packages necessary to knit the file, you will, R is going to prompt you to knit it, but load those packages. Knit-R is one of those. But once you have installed those packages, you can knit the file to HTML, and your output is going to look like an HTML file as follows. Okay, so where is my HTML file to share? So your output is going to look as follows. So this is your knit file, and it's going to be the HTML file. So the name of the file is R1 help, correct? And it's going to be inside the folder that contains the RMD file for R1 help. And that is in this folder over here in my computer. So here is the file that you knit. And this was the original R1 help. And what you need to do is you need to use this file as a submission for the project. So that is the basic stuff for everything that is relevant to this project. Moving forward, we will have more things to work with, but play around. So this is just the beginning. You can now use this as a starting point for other things that you might want to play around with, right? So don't just stop at finishing this project. Try to identify things that you can play around, right? What are the different kinds of sequences that you can do? What are the different kinds of plots that you can do? You have taken calculus 2, try to plot the various functions that you have come across in calc 2 to be able to, see or visualize them in R. Yeah. Working with data sets, play around, see if you can Google and find other data sets to work with. There are various data sets available. See if you can modify those. So the idea is that this is a launch pad for your imagination, and I'm hoping that it inspires you to go ahead and use it as that. That's all for today. You have a good rest of the day, and see all of y'all sometime, somewhere. Enjoy.